Something is happening right now that has every space agency on edge. The interstellar object known as 3I Atlas, the third visitor ever confirmed from beyond our solar system, just did something no one thought was possible. It changed course, not slightly, not subtly, but in a way that breaks every known law of celestial mechanics. For the first time in history, the International Asteroid Warning Network, a United Nations-endorsed global defense coalition, has begun tracking an object from another star system. But why now? Why this one? Because new data suggests that 3I Atlas isn't where it's supposed to be. Not according to NASA's Jet Propulsion Laboratory, not according to orbital predictions, and not according to the fundamental rules of physics. If this object really altered its trajectory while near the Sun, then what we're witnessing may not just be an astronomical anomaly. It could be intentional. The International Asteroid Warning Network, or IAWN, has one purpose: to detect and prepare for threats that could endanger life on Earth. It's a coalition of the world's most powerful observatories, from NASA and ESA to China's Purple Mountain Observatory. Until now, it has only ever monitored near-Earth asteroids debris born within our own solar system. But in late October 2025, the IAWN made a stunning announcement. For the first time ever, it would begin tracking an interstellar object, 3I Atlas. The official reason was to improve astrometric precision on cometary bodies, but the timing was suspicious. Just days earlier, 3I Atlas had vanished behind the Sun, and independent astronomers began reporting small deviations in its expected position. It was supposed to reappear along a predictable arc. Instead, the math stopped working. Avi Loeb, Harvard astrophysicist and author of the Loeb scale, had already rated 3I Atlas a 4 out of 10 on the likelihood of being artificial. Then, after these new anomalies, the IAWN quietly upgraded it to a priority target. Hundreds of telescopes were redirected to track it, as if Earth itself was preparing for something we weren't supposed to see coming. The first hint of something wrong came from an independent group of astronomers known as Earth Exists, a small but respected research collective. They compared live telescope data with JPL's Horizon System predictions, and what they found made headlines overnight. 3I Atlas wasn't just off course by a few hundred kilometers. It was 1.1 million kilometers away from where it should have been, roughly 3 times the distance between Earth and the Moon. The displacement wasn't random. The object's distance remained consistent, but its sky position shifted laterally as if it had moved sideways through space. This breaks orbital mechanics. Comets can drift forward or backward due to outgassing jets of vapor that act like natural thrusters, but they don't move laterally. To make this happen, an immense external force would be needed, or an internal one. Even the largest comet ever recorded, Hale-Bopp, couldn't achieve such precision or power, yet somehow 3I Atlas had done it. If 3I Atlas had shifted its orbit intentionally, then someone had to have noticed before the rest of the world. And that's when attention turned to NASA and JPL. As early as September, NASA's Mars orbiters had been perfectly positioned to photograph the object at close range during its solar flyby, but those images have never been released, not a single frame. Internal sources claim the data is being analyzed, but others suspect something more deliberate: censorship. If those images show structural geometry or light behavior inconsistent with a natural body, NASA would have every reason to delay public release. In one of his recent publications, Avi Loeb mentioned that 3I Atlas exhibited an antitail, a jet of material pointing toward the Sun, an extremely rare phenomenon. But after the Mars encounter, the tail flipped, suddenly flowing away from the Sun again, as if the object had reoriented itself. No natural comet has ever reversed its jet direction so cleanly. And yet, despite the strangeness, NASA insists it's routine cometary activity. Still, the question remains: if it's routine, why is the Asteroid Defense Network involved at all? By the end of October, new tracking data confirmed what everyone feared: the deviation was real. Over a span of 19 hours, the positional discrepancy widened by over 4 arc minutes, equivalent to hundreds of thousands of kilometers. According to orbital analysts, maintaining that drift would require a lateral velocity of nearly 4 km/s, more thrust than some of our own deep space probes could ever produce. Theories exploded across the community. Some said it was outgassing, others blamed solar wind. But solar wind doesn't push sideways. If the data is correct, 3I Atlas would need a propulsion system capable of sustained acceleration and precision maneuvering. Meanwhile, the IAWN's workshop to train astronomers on tracking unpredictable cometary behavior filled within hours. Behind the scenes, NASA's Planetary Defense Office quietly elevated its monitoring level, the same tier reserved for potentially hazardous asteroids. The irony is that the object is moving away from Earth, not toward it, so why treat it like a threat? Some believe the answer lies in something even stranger. It may be planning another turn. Just when astronomers thought the anomaly had stabilized, 3I Atlas changed direction again. This time it wasn't a slight deviation. It was a full correction. Ground-based observatories in Chile, Spain, and Japan detected a secondary deflection, smaller than the first but perfectly aligned with the object's original trajectory, as if it had corrected its own path. This was no random drift. The movement was symmetrical, calculated, and exact, the kind of correction that a spacecraft would execute after an automated navigation check. The IAWN issued an internal alert marked pattern recognition event, meaning the behavior matched no known natural phenomenon. At the same time, the European Space Operations Centre, ESOC, released an encrypted update to its member agencies confirming that 3I Atlas had produced measurable acceleration inconsistent with gravitational influence. In simple terms, the object had fired something. When the Very Large Telescope in Chile analyzed its infrared emissions, it discovered a sudden spike in thermal radiation, a burst lasting 12 minutes, followed by complete cooling as if a controlled engine had ignited and then shut off. Whatever 3I Atlas was, it had just proven it could move on its own. The moment the data went public, every space agency scrambled. NASA doubled its monitoring schedule. China reactivated its U-22 radio array, normally used for lunar missions, to track deep space frequencies coming from the object's vector. The European Space Agency deployed emergency protocols from its Planetary Defense Office, a move typically reserved for imminent impact events. Officially, this was to ensure coordinated observation. Unofficially, it was panic. Scientists from Caltech and the University of Tokyo began comparing 3I Atlas's acceleration pattern to known artificial propulsion systems. What they found was eerie. The heat curve of the burst didn't match any chemical reaction or known ion drive. Instead, it resembled a magnetohydrodynamic acceleration signature, the kind produced when charged plasma is guided by electromagnetic fields. It's the same technology humanity has only theorized for interstellar travel. And it wasn't just propulsion. The object's rotation rate, previously stable, began to fluctuate in harmonics, repeating every 247 seconds. At first, astronomers thought it was tumbling, but the pattern was too precise. It was communicating through motion. With each new observation, the International Asteroid Warning Network expanded its scope. What began as a scientific collaboration was now operating like a defense task force. The object's new heading pointed not toward interstellar space but toward the outer planets, specifically Jupiter. Analysts calculated that within months, 3I Atlas would pass dangerously close to the gas giant, within its magnetosphere, a region capable of generating immense energy.